So let's take a look at algorithms because I think this is useful. So, common problem that we like to use when we're talking about algorithms is the problem of finding prime numbers. Okay, so what's a prime number? Prime number is, yeah, it can only be divided by 1 or itself. Simple definition. So if I wanted to find all the prime numbers between 1 and any number, how would I do that? Just in regular words, how would I figure that out? What would be the easiest way? Well, yeah, I could do that. I could, if just in regular words, if I wanted to figure out what are the steps I'd go through, I would start with 2, and I would say, okay, what numbers could I divide 2 by? Like if I'm finding all the prime numbers between 1 and 10, okay, we know that those numbers are 2, 3, 7, 2, 3, 5, 7, and that's it, right? Those are the prime numbers between 1 and 10. So I would start with 2, and I would say, what can 2 be divided by? Then I would check 3. What can 3 be divided by 3? Yes, we know 3 and 1, because that's every number can be divided by itself and 1. Can it be divided by 2? No. So yes, it's a prime number. Then I would do 4. I would say 4, can it be divided by 3? No. Can it be divided by 2? Yes. Okay, so that's not a prime number. So I'd go through that list, and I would be able to figure out, although it would take me a really long time, all of the prime numbers, right? So our algorithm involves 2 basic things, right? If I am going to say write the prime numbers between 1 and 10, I have to be able to count 6, 7, 8, 9, 10. I have to be able to count to 10. And then for each one of those, I don't need to divide by 1 or itself. So that's it for that one. 2 and 1 are the numbers that I would have to divide by. We know that's prime. On this one, I would divide 3, 2, and 1. Okay, so those don't matter, and this one doesn't go evenly. So that's prime. I would go 4, 3, 2, 1 here. Those don't matter. That doesn't go. That does go. So this is not prime. And so on. So I would have to have something to count here. And for each one of these, I'm going to divide by all the numbers between that number and 1, right? Including that number. So there's 2 parts to that. So I have to have the counter, and I have to have something that says, is this number prime? Is this number prime? And that is the dividing part. So if I want to write this out, the first thing I want to do is get a number from the user. So let's just get a number equals int input. Give me a number. We'll be forceful about it today. Okay, so that's where the user inputs the number. Now I have to have a counter that goes from 1 to that number. If I have a counter and I want to use a range, remember that a range doesn't include that last number, but it doesn't matter because we already know that if I divide 4 by 4, it'll go in. So I can actually stop dividing at 3 and save myself a little bit of computing power. Okay, so I need to have a counter now. So my counter would be for int test. I'm going to test that number in range 1 to int number. Okay, so there's my counter. As evidence, I can print int test, and when I run that, give me a number, 10, and it counts from 1 to 9. So there is part 1. Part 2 is I have to see, is that number prime? So I will say, here's my counter. Part 2 is it prime? Now, because the is it prime by itself sets up a complicated operation, what I'm going to do is I'm going to create a function for that. So I'm going to say, is it prime? And I'm going to use int test. So each number between 1 and whatever number the person enters is going to be put through this test. So now all I have to do is define that. Is it prime? And I'm going to give it its own integer here as, oops, that's a little hard to read with all my writing all over it, isn't it? That's okay. I'm sure you all memorize that diagram. So I've got, is it prime? And I'm going to feed that a number each time, which will be the number as it goes through each number between 1 and 10. So now, the is it prime, so if the number I'm giving it is 9, I want it to divide by 9, 8, 7, 6, 5, 4, 3, 2, 1. And I can actually skip those because I know it's going to be divisible by those. So I can use a range from 2 to 8, and I can say 9 divided by 2, does it go evenly? How do I know if something goes evenly? What's the easiest way to tell if something goes evenly into something else using Python? No remainder. So I use the modulus. So I go 9 modulus 2 equals 0, right? And if I test each one of these, and this is not a modulus 0, this is not a modulus 0, if I test each one of these, all I need is for one of them to say, yes, it'll go evenly. And then I know 9 is not a prime number. So I have to set up that condition in this to say, is it prime or no? So I'm going to say, we're going to start out assuming that it is a prime number. Why? Because that's easier. And as soon as it only takes one of these, then I'll flip it to false. Then we know it's not prime. So I'm going to say for int x in range, and I'm going to start at 2 because I know 1 is going to be a divisible, and I'm going to stop at int n2, or actually the number below int n2, because I know 9 is divisible. So I'm getting 2 through 8 if the number is 9. And I'm going to say if int n2 divided by, or modulus, int x equals 0, or actually if it equals 0, which means it goes evenly, Then we're going to flip prime to false. And honestly, if I start at 2 and I go 9 divided by 2 has a remainder of 1, okay, that's not it. If I get to 3 and I say 9 divided by 3 has a remainder of 0, I know it's not prime at that point. Do I have to continue? No, I'm done because it's already not prime. I don't have to care if it's divisible by anything else because I know it's divisible by something that is not 1 and not 9. Therefore, it's not prime. So I'm going to put a break in here because that'll save me some computing time if I'm getting to a larger number. And then I'm going to go back out here and I'm going to say if Boolean prime equals false, then I'm going to print. Actually, I'm going to say true. I'm going to say if it's still true, then I'm going to print, because I want to only tell it the prime numbers. I'm not going to, if it's false, I'm not going to print anything. So we'll use an F string here and we'll say int n2 is prime. So there's my is it prime. It'll take a number and it'll figure out if it's prime or not. So I'm just going to test, because remember, I'm going to break this. I'm deconstructing it. I'm solving a problem. So I broke it down into a problem of how do we figure out what a prime number is, whether something is prime or not. So now I can say print is it prime, and let's go with 10. So I run that and it doesn't do anything. If I do is it prime 7, then it says 7 is prime. Let's try a couple others just to make sure that I'm not just on a lucky streak here. 11 is prime. 21 is not prime. Okay, so we're good. I could have it say, I could throw an else in here and say, is it not prime? But when I put this in the context of my larger application here, I don't want it to, oops, didn't mean to do that. I don't want it to print every time something is prime and isn't prime.
Professor, how did you do that where you delete all the hashtag all at once?
Selected it and I hit command / on the Windows machine. I think it's control /. Yeah, you can comment and uncomment a whole block of code by doing that. You can also use tab and shift tab to tab over or tab back. A lot of good things you can do. And if you want to collapse this block of code, I think it's command period or control period will do that. It doesn't make it go away. It just gets it out of your way for a minute.
Because I did that and deleted the whole thing.
Control Z is your best friend in that case. That's undo.
Really?
Undo.
Control Z doesn't undo.
Yeah.
I learned the hard way too.
I stressed out. I was like,
Yeah, it's terrible when that happens. So now if you hit Control Delete, it'll delete a whole line.
I did backspace by accident.
Yeah, that will do the whole line. But undo, see, look, I can do that. Delete it, undo, I bring it back. Just like magic. Undo is your best friend. Okay, so here's my whole program. I've defined my function so I can collapse it because it's a good black box for me. I know what it does. I know what I give it. Don't care how it works. So there it is. I'm going to get a number, and I'm actually not even going to print the number unless it's prime. So I'm going to comment that out too. So really, once I have this defined, I've got 4 more lines of code or 3 more lines of code that are required to make this program work. And let's run it and see what it does. Give me a number. Let's start with 10. There we go. 1, 2, 3, 5, 7 lists all the prime numbers. In case you're wondering, you can go pretty big here and it'll still figure out all the prime numbers. Now remember, every time it goes through this, it's getting more and more division problems. So if I want to do something like 10,000, I mean, we're still not taking that long. If you go up into like the millions, then it takes a few minutes to churn through all of it. But that's more of a PyCharm limitation than a Python limitation. Uh, but it's surprising to me that you can get these really big numbers. I don't know. Math is weird because there's 100,000. So you can get these really big numbers that are literally only divisible by one and that number. And it kind of blows my mind a little bit that you can get numbers that are that big that are actually prime. So the biggest number below 100,000 is 9,991. If you start looking at this pattern, this is not anything to do with Python, but if you start looking at the pattern of prime numbers, that's interesting all by itself because there is a pattern of primeness, if that's a word. So anyway, that's a little sidebar. But the interesting thing about algorithms is that they all kind of work similarly. And what I want you to do as you move forward is try and employ algorithmic thinking in terms of solving these problems or these assignments and sandboxes that I give you.